Hey, what's up, guys? This is Chung here. So this time I want to talk about today's daily challenge problem, number 713, subarray product less than k. Pretty good medium problem. Okay, so you're given like an array of positive integers. Okay, so this every number is positive, and it asks you to count and print the numbers of contiguous subarrays whose product of all the elements in the subarray is less than k. Okay, and yeah, so mm, I mean this problem, I think it can be solved in a binary search solutions, and but a better solution is just like using a sliding window, like with two pointers. So basically, what's this problem is that, the key observation is this. Uh, we have this array here, x, x, x. Okay, so let's see with this range of the with this range of the data. Okay, if everything basically if everything inside this sliding window is it satisfy the product of everything inside the sliding window here is smaller than k, then we know the total number here of what is this is 1 plus 2 plus 3 plus 4. Basically, that's the total number of the subarrays, right? Who's because since the longer the bigger the sliding window is, the bigger the product is, right? Basically, if this thing is smaller than k, so any of the subarrays inside of this sliding window is also like a valid subarray. So basically, so all we need to do is just that we just need to loop through each of the numbers here, and we use that one as the right pointer, okay? Because the reason being is that let's say we have a again we have this x here. Let's say everything inside here is like it's satisfied the case here. So at the beginning, when we are at the first here, the first one here, the uh, the left pointer is pointing to here, pointing to the beginning of the array here. So our right pointer is this one, okay? So if this one satisfy our conditions here, so then we have the total subarrays we have is 1. And now the right pointers move to here. And if this one also satisfy our conditions, so basically we have two more like subarrays. So what are those two more subarrays? The first one is this element itself, and the second one is basically the length of this one, the length of the current sliding window minus 1. That's why we have a 2 here. And let's keep moving, right? So now if we move to here, if still it satisfy our condition, so now we have 3 more elements here. So 1 plus itself, okay? 1 this is the itself, and the other one is this one. It is from the 2 to the third one, okay? And the last one is the 3 itself, the whole array itself. So the more we have, this is 4 here. Okay. So let's say we have 4 here. And then let's say when we move to here, when we're moving to here and the total product is exceeding it's greater than the k here, then we cannot add 5 here, right? Because that's not the valid move. So basically, if that's the case, we just try to shrink the left pointer. Let's say if we shrink the left pointer to here, okay, to here, and then this thing satisfy our current conditions, okay. And then instead of 5 here, we need to add 3. Okay. And then we just loop through everything. We just keep going until the right pointer reach the end. Then we have our total answer here. Cool. So let's start coding here. And we have, what do we have? We have a left equals to 0. Okay. And then for right and number in enumerate nums. Okay. And then we have an answer here. Answer is like the 0. And we also need a current product. Okay. Equals to 1. Since so every time we have a current product times with the current number, okay, while current product is equal or greater than k, okay, then we do a current product divided by the basically we're trying to update the sliding window so to get to a valid to get to the valid point here, and nums of the left, okay, and then we do a left plus 1. Okay, now we have a valid sliding windows. Now we can simply add our answer, right minus left plus 1. Okay, yeah, and in the end we simply return the answer. Hmm. Yeah, I think that should work. I mean, nah, here. Okay, cool. So submit. Hmm? Uh, oh, here. So when the k is Yeah, so basically when the k is equal to 0, then it means that, or even more, so when the k is equal or smaller than 1, then uh it means that there's no subarray that is less than k in this case, because every single element is greater than 0, which is starting from 1. Okay? So if that's the case, right, I mean, for everything inside here, it will always be greater than the than the than the k here. So we'll just keep moving the left pointer. So that's why we have a invalid index exception here. So we can simply do this. If the k is equal or smaller than 1 here, we simply return 0. Yeah, yeah, cool. So accept it. I mean, and yeah, the space complexity, right? I mean, the other part is O of n, right? That's for sure. And how about this one here? It seems like we have a nested n inside here, but you know, notice that the left is always increasing. So in total, we have like also a n here, a n of a while loop here inside of the for loop here. Basically, it will not like be gonna be a nested on loop here. So it's gonna be a on plus on, right? So in total, it's also on or O of n. Yeah, I think that's pretty much for this problem. I think one thing I stumbled a little bit was the at the beginning I was able to find out like the for this kind of things here. If we have a stable, a valid sliding window here, I mean, I was trying to get everything inside here. Basically, that's going to be the n times n n n minus 1 divided by 2. That's a total number, total number of valid numbers here. But then, I mean, that's only one part, right? But how about if we're trying to move the sliding window, right? If we're trying to move the sliding window here, how can we update that? Okay, I mean we can update that. I mean, because before I was trying to use like the left pointer. I was trying to use the left pointer in the for loop. So basically, I was trying to see from here onward, from this left pointer here, what is the biggest window, sliding window we can extend from here. Okay, but then that's not a right solution because if we are trying to go into here, we're gonna cover some duplicated numbers along the way here, and yeah, and here if we're trying to count from the left point side, right, we have to count everything. But if we are counting from the right point side, all we need to count is the how many new subarrays this new right pointer number can give us. This is definitely a better solution. Okay. Okay, cool guys. I think that's what I want to talk about for this problem. Yeah. Okay. Thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.